Hi friends, welcome back. We're going to look a little bit more in depth in vertex form today. In the last video, we looked at what vertex form was and maybe why it's useful. Today, this video is going to look at how do you use it. So if we were looking at a quadratic in vertex form, how would we graph it? Well, we want to keep in mind that to graph, we need three important points. We need the x-intercept, we need the y-intercept, and we need the vertex. So this is a unique form, vertex form. In vertex form, the vertex is a lot easier to find. These can be a little trickier. In standard form, these are usually a little easier to find, and the vertex can be a little trickier. So we're going to look at finding these to graph today. We're not going to actually graph them. I know you can plot points, but how do you find all of them? So just to recap, vertex form, y equals a times x minus h squared plus k. And then if it's in that form, we can just pluck the h and the k right from it for our vertex. So that kind of takes that one right out of the box. So we're going to look at our first example here. Vertex is usually where I start if it's in vertex form. So I have my minus inside my parentheses, which if I go back, I have to have. So my vertex, my x is 2. And then I need plus k. I don't have plus k. I have minus 9, so this must be the same as plus negative 9. So negative 9 is going to be the y value of my vertex. So vertex is a little easier to grab. Y-intercept, again, not super difficult because we know that at the y-intercept x is 0. So what we need to do is we need to plug 0 in for x. So 0 minus 2 squared minus 9. 0 minus 2 is negative 2. Negative 2 squared is 4. And 4 take away 9 is negative 5. So negative 5 is my y-intercept. So again, very similar. Now, a very common mistake students will make is they'll say, oh, negative 9, that's my y-intercept. It's like my c value in standard form. Not the case, because when we plug in 0 here, we have to do something to 0 before we square it with giving us a value. So don't just take this negative 9, make sure you plug 0 in. All right, x-intercepts. X-intercepts are going to take a little bit of algebra. We're not going to factor. We're going to solve. So at the x-intercepts, we know y is 0. So this step takes a second. So 0 equals x minus 2 squared minus 9. So it's just kind of like 0 pi power when we replace the y with 0. Now we're going to just solve. We're going to solve this equation. So how would I do that? Well, I'm just going to use my basics. So I need to work down to isolate my variable. First step is I'm going to add 9. This is going to leave me with 9 equals x minus 2 squared. Now I have to get rid of my square, so I'm going to square root and square root. This will cancel out my square, leaving me with x minus 2. But on the left side, if you recall, when we solve, there are 2 roots of 9. There is plus 3 and minus 3. So what this does, it's very similar to our absolute value problems. This is going to split us into 2 equations to solve. We have to use the positive 3 is equal to x minus 2. So I take that positive 3 equals x minus 2. And then I'm going to take the negative 3 equals x minus 2. Add 2, I get an x value of 5. There's one of my x-intercepts. And then on the other, I'm going to add 2 and I get x equals negative 1. There's my other x-intercept. So when we want x-intercepts, we have 5, 0 and negative 1, 0. And that is how we find all 3 parts from vertex form. Now this video is going to be kind of long, so I maybe take a break right now. We got 2 more problems to do. This is the longer video for the week, but I'm going to continue. All right, I got another one. We're going to go through all of those steps again, maybe a little quicker this time. Vertex. Well, this is in vertex form. This needs to be minus. It's not, so this must be the opposite. So -5, because subtracting a negative makes +5. And then this should be plus. It's not, so plus -12, if I made it like that. So -12 is my y value. Vertex, done. Y-intercept. Remember, 0 goes in for x. 0 plus 5, 25, or excuse me, 5. 5 squared, 25. 25 minus 12, 13. So there's my y-intercept. And now x-intercepts. Well, I got to bring this over and replace y with 0. Okay, this one's going to be a little tricky. If you're seeing it already. All right, first step, add 12. This gives me 12 equals x plus 5 squared. Have to undo the squaring, so I square root both sides. That's going to give me, all right, well, let's start with the right side, x plus 5. On the left side, I don't have a perfect square, so it's not going to come out to a nice number like it did in the last problem. So here's what I'm going to do. I'm going to leave it in what's called exact form. So I'm going to say plus or minus the square root of 12. All right, now I need to split these up. I need a positive square root of 12 equals x plus 5. And then I need a negative square root of 12 equals x plus 5. Now when I solve this to keep it exact, I'm just going to subtract 5 on both sides. So my answer here of x is going to be the square root of 12, or the positive square root of 12, take away 5. And on this side, I'm going to take away 5, and my x value is going to be the opposite of the square root of 12 minus 5. And I'm going to leave my answer as so, in exact form. Now you can do that. That's fine. Our quiz isn't going to have those answers. So here's what we would do. We would just approximate it. So I'm going to take my calculator. I'm going to do this one first. The square root of 12 minus 5. So about -1.54. So I'm going to say x is about -1.54. And then for the other one, the negative square root of 12 minus 5. X is approximately -8.46. Now notice we got some really goofy x-intercepts there. This would have been a quadratic that, if it was in standard form, would have been unfactorable, but still has x-intercepts. They just aren't integers, which is why it wasn't factorable in our understanding of being factorable. All right, hang with me. We got one more problem. It's a quick one. Y equals the quantity x plus 1 squared plus 16. Vertex. -1, 16. Y-intercept. Plug in 0 for x. That's 1. 1 squared is 1. 1 plus 16 is 17. So vertex and y-intercept, take a little quicker on these. The last one is the x-intercept. So 0 for y, x plus 1 squared plus 16. Maybe you're seeing a problem already. Let's go ahead and solve. Take away 16, take away 16. Negative 16 equals x plus 1 squared, square root. Uh-oh. Square root of negative 16. Can't do it. Can't do it. So what that tells us is since I can't solve this, there are no x-intercepts. There are no x-intercepts for us. So we're going to say no x-intercepts. And if we think about it from the vertex and the y-intercept standpoint, if I had my graph and I have a vertex at negative 116 and I have a y-intercept at 0, 17, it's opening up and its vertex is in the second quadrant, so it's never crossing the x-axis. That's why there are no x-intercepts. So hopefully this helps. How do we use vertex? How do we find those 3 points? And then if we were asked to graph from the vertex, we would just plot those special points. We would plot those special points. So if I had this original problem, I'd plot the vertex, plot the y-intercept, plot the x-intercepts, and connect them. I know this was a longer video, but this one takes a little bit of explaining. So hopefully this helps. If you have to rewatch or pause parts, please do, and we'll look at something new in the next video. Take care.